This video is going to focus on thermodynamically favored processes, or spontaneous and non-spontaneous processes. A thermodynamically favored process is one that proceeds without any assistance from outside. For example, we know that water is going to evaporate at 25 degrees Celsius. That's room temperature. If you leave a glass of water out with just a tiny bit of water in the bottom, you come back the next day and it's been evaporated. Iron is going to rust when there's oxygen and water, like if you leave your bicycle out overnight and it's raining. Salt is going to dissolve in water. So these are all processes that happen without any extra assistance. So a non-thermodynamically favored process is going to be one where assistance from the outside is necessary. For example, water is not going to boil at 75 degrees Celsius and 1 atm. Now, if we raise the temperature of the water or reduce the pressure, this process would become thermodynamically favored. Water is going to boil when the vapor pressure equals the atmospheric pressure. Our second example, water does not freeze at 15 degrees Celsius, but if we lower the temperature, then the water will freeze because that process is favored at 0 degrees Celsius. And the last one is an industrial process where you have rust, the iron oxide, and carbon changing into iron and carbon monoxide gas. This does not spontaneously happen at 25 degrees Celsius. There are smelting processes that take place at high temperatures where this reaction is favored. So a thermodynamically favored process in one direction is not going to be favored in the other direction. So either the forward or the reverse will be favored. For example, water is going to freeze at temperatures below 0, but the reverse won't happen. You have to change the conditions, like raising the temperature to get the ice to melt. Exothermic reactions are favored more often because nature tends to favor processes that cause a reduction in energy. So remember, in an exothermic reaction, the bonds and the products are going to have less energy because energy is released when those bonds are formed. Endothermic reactions can be thermodynamically favored. So, for example, if you feel cold as water evaporates from your body because the water is pulling heat out of your body to drive the endothermic process. It's like when you sweat. When your grill is on, you can feel a cold spot on the side of the propane tank where the liquid is turning into a gas, and that's happening at the liquid surface. In this dissolving example down here with the salt, most ionic compounds, the temperature of the solution is going to decrease during this dissolving process. So all three of these reactions are going to be endothermic and thermodynamically favored.